Okay, recording has started. Got the message. Yes, thank you, mate. Let me make sure everyone can see my screen. I'm just going to play this slideshow. I'm going to flick through these pretty quickly. Feel free to chime in and ask any questions as we go along. Can everyone see that first GitLab University slide there?
Affirmative.
Excellent. Okay, great. So yeah, let's just go through what I'm going to basically run through. But we're going to talk about this market ecosystem. But firstly, we're going to have to define the market just to basically get an overview of where we sit in the whole scheme of things in terms of our technology. And then take a look at how that market's evolved over the last 10 or 15 years. There has been some pretty dramatic changes, so that's worth reviewing. Have a look at the core tools in this particular market that we're in, and where basically GitLab fits in and where our strengths are. So if we basically, define the market, the overall term that's been thrown around for a long time now is called application lifecycle management. It's kind of a catch-all phrase to basically, capture the oversight and development and maintenance of computer programs. So this involves everything that goes into a software development project, from its requirements at the beginning all the way through until deployment at the end. So this is basically just a simple diagram of all the elements of application lifecycle management. Our particular tool is just sort of one component of application lifecycle management. There's a lot of other areas that we don't necessarily go into. For example, say resource management is one area, or say requirements management. They're kind of adjunct tools that tie in with something like GitLab, but nonetheless, they are still part of application lifecycle management. So if you hear the term ALM, that's kind of a blanket catch-all phrase for the kind of space that we're in. It has evolved dramatically over the last kind of 10 years. And the biggest thing that is forcing this evolution is the need for speed and agility, and basically increased quality. So these are all things that at the business level, when you're talking to, say, VPs, they're going to be basically focused on how can they get their product out the door quicker with less bugs, less regressions, etc. So they're looking to deliver value to their customers, whether that's their internal users, like within a company. Maybe they have a custom application for their employees that somebody's building and their customers are internal, or it's external customers like us. Companies that buy your software, pay you for it. So at a very, very high level, the pressures on ALM tools and processes are really about speed, agility, and increased quality. And what that's done in terms of software development in general, this graph's been around for a while, and some of you may have heard these terms, but if we go back, say, 10, 15, 20 years and beyond that, it used to be all about waterfall, which is a development methodology. People still use it today, although it's kind of phasing out. And that was pretty much an era where there was heavy requirements up front. There was a lot of design and scoping out of a project and coming up with all these big requirements. And then the development team would go away and code for basically 6 months, even to a year, and then they would release this product at the end of the period. And it may or may not have delivered the value that the people were looking for, or perhaps their requirements have changed in that time frame. So waterfall was pretty much an old methodology, that had pretty much a single annual release or a semi-annual release. So there was a lot of planning and scoping up front with all these large set of requirements. Team would go away and code, and then voila, they would deliver the product, and then they'd be scratching their heads going, well, things have kind of changed since we put this together. So that's kind of what waterfall was. And then we moved into this era of agile, which has kind of been ongoing for the last 10 years, and we're still kind of in the agile era, but we're in a more extreme form of agile. And that was basically where, instead of having these really large chunks of requirements set up front, you would basically break them up into small increments of change, small features, smaller products, and basically shorter release cycles, shorter coding cycles. So you would set a feature. If your customers, whether internal or external, required some sort of new feature, you would just focus on that new feature over a short period of time and try to get that out the door. And you could do that because some of the processes in the process of development you could automate. For example, one of them would be, say, continuous integration. You could basically automate your builds and testing, so that when you had this feature built, you could run it through the testing cycle, run it through the build cycle, and get some results pretty much immediately, so you knew whether that feature was ready to go out the door. So that was kind of what Agile is about in a nutshell. It was just smaller incremental changes in a shorter period of time. And if you move kind of to, nowadays, say in the last 5 years, we're more at the kind of extreme end of Agile, where it's basically continuous development, continuous integration, and continuous delivery. And that's basically about micro changes, almost to the point where every single commit that a developer does gets built, it gets tested, and in some cases it gets released. So a good example of that is, say, our website. Well, actually, let's take Amazon's website. Now, there's a statistic that says they release every 11 seconds. So there's changes happening in their development organization on the back end, and they're able to push those new changes out to their website, their e-commerce site, every 11 seconds. So that is basically continuous delivery. That's what they're doing. They're still working on very small incremental changes to their whole product, whatever that might be, and an extremely short amount of time. And rather than waiting for an annual release, a semi-annual release, monthly release, they just push it out the door as soon as it's been validated through testing and continuous integration. So that's kind of where we are now. That's how it's evolved over the last 20 years. Quite a big change, and it really has leveraged all the automation that we're able to do now. So we can push stuff out the door faster and with less bugs. Any questions on that? I think it's a key. You don't necessarily have to, you won't be talking about this, but when you're talking to people, they're thinking about this. They're on the spectrum moving from waterfall to continuous delivery. If they're still on Subversion or ClearCase, chances are they've been doing waterfall. They've started to implement Agile, but they want to move to a more continuous delivery model, and they want to get some new tools and processes in place to enable that. So that's why people are coming to us to get GitLab in-house, because they want to move to a more continuous delivery model.
So, Hayden, I have a question.
Yep.
When you talk about continuous delivery, we talk about continuous delivery and continuous integration. Are they the same thing, or how do they relate to each other?
Yeah, you'll often see those terms used interchangeably. CI/CD is a common acronym people will have on maybe their LinkedIn profile or something like that. Yeah, CI, continuous integration, is kind of one element of continuous delivery. So continuous integration is basically where you offload changes to your build machines that compile the software to make sure that the product can build. The changes that you made didn't break the build, and then it runs a series of tests and then provides feedback to the developer that they passed. They passed the build, they didn't break the build, the test ran successfully. That's basically what continuous integration is, and which is just one element of continuous delivery. Does that make sense, Pitch?
Hey, Hayden, question. So you mentioned that if someone's using Subversion, that's in the waterfall stage. Would it be safe to say that if they're using a Git solution, they're in the continuous stage? And if so, how do we identify? Is there questions that you would ask to identify kind of where they're at in terms of their methodology, or technologies they're using to identify where they are in their methodology?
Yeah, I would say it's a good indicator of so the types of tools they use is a good indicator of where they might be on this whole spectrum. It's probably not definitive. You can still do agile and continuous delivery with, say, something like Subversion or even Force, but it's just that the new kind of workflows with the Git enables and these whole Git management systems are more conducive to continuous delivery. And you can ask them straight up, when you have a prospect on the phone and you're just doing a discovery call, you can ask them straight up, hey, where are you guys on in terms of, moving towards continuous delivery? Are you practicing it now? Are you headed in that direction? Is that an initiative that you're working towards? A lot of evaluations for Git tools fall under this greater umbrella of continuous delivery. There'll be a CD champion internally who is tasked with implementing the tools and process to enable CD throughout the company.
Can you say that question again? Like, where are you at with your?
Yeah, you could just ask them straight up. Just say, hey, in terms of development, where are you on the continuous delivery spectrum? Are you starting out? Do you feel like you've reached a state where you're continuously delivering software, or are you still kind of practicing waterfall and implementing agile, for example? So just ask them straight up: Are you practicing continuous delivery now, or is that something that is a goal?
Great, thank you.
Sure. Any other ones on this? Okay. We'll keep going. So this is basically the core principles, and it's pretty important to understand these. Again, you won't necessarily need to be talking to customers about this, but it's pretty important that you understand what continuous delivery is about. It's a really rapid cycle of essentially, designing your product or designing a feature, a piece of a feature or an improvement or an enhancement. Developing it, testing it, and releasing it in a very quick succession. And that cycle just repeats itself. So you've probably heard the term fail early and often, or break early and often. That's what this continuous delivery is about. So you make a change to implement a new feature, you test it, you release it, and maybe it doesn't work. Maybe something's changed, the requirements have changed, it didn't quite deliver what the customer wanted. So you go back again and you do the whole iteration again. You change it, you develop it, test it, release it. This is the continuous delivery kind of in a nutshell. You can expand it out. There's a bunch of other elements to it, but this is kind of the most simple diagram I could find. And this is what people in their development, this is what we practice internally. We build our product the minute that someone makes a change. It runs through GitLab CI, brings back the results, but we release it on the 22nd of every month. So we are, in fact, practicing continuous delivery, adding new features, testing them, releasing them, getting feedback from our customers, going back to the drawing board and changing it again. It's that cycle of delivering value, getting feedback, and improving it again and again and again. Make sense? One of the biggest forces behind this whole change is DevOps, and DevOps is pretty. If I kind of go back for pre-DevOps, and I'll define what DevOps is in a second, but DevOps is really IT organizations taking advantage of automation and virtualization, which I think Yob talked about in one of our previous GitLab universities, the notion of virtualization. Before the DevOps movement kind of came around, development and operations were two separate organizations that really didn't really talk to each other that much. They just kind of were siloed. So what you would have, and I've seen this picture before, it's kind of funny, but what this picture says is, well, I'm a developer, I implemented a feature and it worked fine in my environment, and now I pass it off to operations to release it out the door, and they're having all sorts of problems with running it on some sort of environment. Basically, it's not my problem anymore. It worked fine when I built it and developed it. Now it's your problem. That was kind of before DevOps movement. And what happened was that all these siloed groups like technology operations, basically IT operations or engineering operations, your software development organization and QA, they're all talking to each other now, very tight knit, and a lot of them are working in the same types of tools. And the DevOps movement kind of falls in the middle. And it kind of the easiest way I can summarize it is DevOps teams basically have the ability now to provision development and production environments very, very quickly because of the use of virtualization and containers like Docker. So in the old days, for example, at Perforce, I remember 10 years ago, they were not practicing DevOps or continuous delivery. You would have and Perforce is a piece of software that runs on, it's multi-platform. It runs on Windows, Linux, any type of platform. And so does the GUI. It can run on, you can use a Windows client, you can use a Linux client. It's all cross-platform. So when the development teams, would have a new release coming up, they would have to test it on all these different platforms. And the IT team would have to provision, literally go out and buy new hardware, buy a new computer that had a Linux, kernel embedded in it, where these teams could actually do their testing. We had a lab set up with a bunch of computers in it. One was a Windows machine with an x86 processor. One was a Linux machine with a 64-bit processor. So they would actually have to go and get all this stuff in-house, and it would take them months to buy it, set it up, set up the lab, and then the development teams could come in and make sure that their changes would run on in these environments. Nowadays, basically all the IT teams can take advantage of automation, and they could spin up these testing environments really quickly. They could spin them up in the cloud because they have containers like Docker to say spin up a new Linux environment, so a developer can test his new app on in that environment before it gets released to customers. And you might have heard the term infrastructure as code. Well, that's kind of what this is. It's basically your IT teams that have all this code that they want a version too. They actually want to put that into a version control system like Git. And that code is basically a recipe, so to speak, for a particular environment, whether it's a development environment or production environment. And they can just run that configuration script, and it'll spin up that environment really quickly, like in a matter of seconds. And then they can tell the developer probably gets an automatic email, hey, your environment's ready for testing, and off they go, and they go bang on their new piece of software. So this is kind of a pretty big piece to understand. It's one of the driving forces behind continuous delivery is the notion of DevOps. Any questions on this one? Okay. So let's go into the core tools. If we take our continuous delivery graphic and we talk about the tools in each kind of section, I've tried to break them down into, the different sort of elements or buckets, so to speak. So in the design phase, these are the kind of tools that fall into that. So in terms of requirements management, for example, Zach worked at Rally. Rally is a requirements management tool. So when you're designing software, you'd use something like Rally to put together, a set of requirements for the product. And then there's all these other tools out there like version 1. IBM has an old product called Doors. And in some cases, people even use Jira because it's kind of robust enough and flexible enough that you can use it for requirements management. And then there's all these agile planning tools, to basically manage your development process. I put them in the design phase. It may not necessarily be part of design, but it's kind of about planning your product increments. So these are things like Handsoft, Greenhopper, and Axosoft. You can look those up. Greenhopper is an Atlassian product. That's their agile planning tool. They're the ones that make Jira. And then there's a bucket load of Scrum and Kanban tools. We've got some listed on our website under applications, but there's a ton more. And they don't necessarily have to integrate with GitLab. It's nice if they do, but you can use them as a standalone tool. So there's a lot of tools in this area. You don't have to be familiar with all of them, But this is kind of where they fit into the whole continuous delivery process, is in the design and planning phase at the start. We don't necessarily have these as part of GitLab. We do get requests for them. In fact, I had one yesterday from someone that said, hey, it'd be great if you guys had your own Kanban board, which is a form of Agile. We might look, Sitchi said we might look at doing something, or we might just integrate with others, which we do right now. So this is where we get into kind of the juicy part, and this is where we kind of shine, is this part here. So in the development phase, these are all your developer tools, and version control being kind of the centerpiece of that. So Git, Subversion, and Perforce are all version control tools. They're not the same thing. They do the same thing, but they are not the same thing. There's a bunch more. There's Team Foundation Server for Microsoft. There's IBM ClearCase. They're all, apart from Git and Subversion, they're all proprietary version control systems. But Git is becoming the winner. Or in fact, it basically is the winner in that regard. IDEs, that's an integrated development environment. You'll probably hear this come up a fair bit, Visual Studio and Eclipse. A lot of developers use Visual Studio when they're doing .NET development. If their company's a subscriber to the Microsoft Developer Network, they get Visual Studio as part of that. So if you hear the term, oh, do you integrate with Eclipse and Visual Studio? If it works with Git, it'll work with GitLab. That's basically our answer to it. Issue tracking is another part of development, obviously. They're all kind of some of the main tools there. We have our own built-in issue tracker, and we compete with the likes of Jira, Bugzilla, HP Quality Center, ClearQuest, things like that. Code review, you can get standalone code review tools. Some are proprietary, some are open source. Crucible is the one from Atlassian. That's a proprietary tool. Review Board is open source. I know a few companies that use a review board. And Gerrit is big in the Android food chain. That's kind of a very similar model to what GitLab follows in terms of branching, putting it up for a merge request, and then getting it approved. It's a little bit similar, but it's kind of very, very popular in Android development.
So Hayden, on this level right there, what we don't offer is something in the IDE. Can you repeat what IDE is again?
Yeah, it's an integrated developer environment.
Okay.
Yeah, so I feel like that they're becoming less popular now as people kind of use tools like GitLab to, they're mostly living in GitLab UI to visualize their branches and, everything to do with their project. And if they're not using the GitLab UI, they could be using the Git command line. The IDEs were, there's a bunch of things. It's got a debugger built into it. There's a bunch of kind of things that developers use on a daily basis that are all integrated into these development environments. That and the most popular being Visual Studio and Eclipse. Eclipse for Java and Visual Studio for .NET. So testing, that's another piece that we handle really well, especially with GitLab CI. So a big part of testing is continuous integration, and there's some tools there. Jenkins is kind of the mainstream one. Electric Command is a proprietary tool from a company called SmartBear. TeamCity, Bamboo is from Atlassian, and Travis we know is kind of hooked up with GitHub. But we have our own. I'll go into our own tools in a second, but continuous integration falls into this testing piece. And then there's testing tools. There's tools that run, basically code tests, but there's other tests that you can run, such as, tests for open source licenses, for example. And that's what things like Black Duck do, or Parasoft, Palamida. They basically go through your code and look to see if there's any third-party open source code in there, and they basically validate that and make sure you got the right license for it, and things like that. A JUnit is, that's a real pure testing tool. It's a pretty common one. And then I put artifact management in the testing bucket too, because once you go through continuous integration and you get these results, you get these build packages or built artifacts or binaries. basically compiled software that you can keep them or you can discard them. A lot of people keep them around for a little bit and then blow them away. But you definitely want to keep your production builds, the ones that actually go live. And you'll end up using some sort of artifact management tool like Artifactory, Nexus, or Maven for Java builds. So I kind of put those in the testing phase there. And then in terms of release, this is kind of where you get into the IT automation part of it. So, development's done their bit. It all works fine. It runs in all these environments. Now it's time to push it out the door. So IT teams are they're provisioning tools. They're using Puppet, SaltStack, things like that, Docker for provisioning these environments. I just put, these aren't really tools. The cloud is basically just the environments that you can push to. They're not necessarily tools, but be familiar with them. So Cloud Foundry we've palled up with, which is great. Makes it easy for GitLab to run on Cloud Foundry. And then the deployment tools, things like Capistrano and Urban Code from IBM. We don't necessarily, go into this area too much with our tools. We're more in the development and testing phase of the continuous delivery cycle, but it's still worthwhile being familiar with these, the deployment and release end of things, because they still need to be integrated with something like GitLab so they can go from development to production really quickly. Any questions on those? They're kind of the big buckets and where they fall in continuous integration, continuous delivery. Oh, actually, I did have one more. Sorry, I'll just cover this one. So these are, I put this down the bottom because it kind of covers the whole spectrum of continuous delivery. No matter what phase you're at, you'll have these collaboration tools. Like we use Slack internally. We use Mattermost. Actually, I don't think we use a Mattermost. It's development using Mattermost. I can't remember. But these are all the tools that developers and whoever else is part of the project can use to collaborate on the project, and they kind of cover every part of CD, every stage of CD. Any questions on that part?
I was going to ask, do you know if GitLab, I've heard the term Chef before. Do you know much about Chef, or do you know if GitLab uses Chef, or what exactly Chef is a little bit more?
Yeah, maybe Sitsi, if you're there, do you mind answering that? You're on mute, mate.
I don't mind answering that. The question is, how does Chef fit into this this model?
Yeah, how do we use Chef, and kind of, is it part of the product? Where does it come up?
Yeah, so Chef is not part of our product. It's just something we use. It's called environment provisioning, which is an appropriate name, but some people also call it configuration management. It's a way to make sure that when you have a running software, you have all these packages and variables you need to fill out, and to do that in a scalable way within the company. Chef is a way to do that. We leverage Chef to make our omnibus packages, which is the way we ship our software. But other than that, we don't have any special links to Chef. There's a proposal I made recently, which you can find on aboutgitlab.com/direction for GitLab deploy. And then we could have like special links to, for example, Chef to upload cookbooks and stuff like that. But for now, we don't have any special relationship to it.
Yeah, so pretty much, yeah, we use it internally. Marin uses Chef to build the omnibus packages. Okay, so where does GitLab fit in? So it's just kind of just a bit of a summary phrase, but we are a collaboration platform that enables continuous software delivery. And if we flip this CD kind of graph on its head, GitLab kind of supports the whole lot in some way, shape, or form. That's the way I see it. And specifically, if we look at our own tools, so for example, you could, if you wanted to, you could use the GitLab wiki for requirements management. You could basically list out, aspects of the product, the direction of the product, features, things like that. You could use the wiki for that. There's no reason why you couldn't. Although there are specialized tools like Rally they just specialize in that. But there's certainly no reason why you couldn't use, say, our wiki. In terms of agile planning, we don't really have a tool for that. There are specialized tools, but you can certainly, and we do internally, we use milestones and we use labels. That's basically how we plan out what's going to go into the next release. For example, you'll see that Dimitri goes along and he'll tag a certain feature with a milestone. So that's certainly one way that we could use GitLab for sort of the agile planning and design phase of things. And then in terms of Scrum and Kanban boards, these agile tools, there's some tools listed on the applications page. If you go to that page on the website, scroll all the way to the bottom, you'll see a few tools there. But there's nothing built into the product in that regard. As I said before, we have been requested it, but it's probably not a high priority because there's a lot of those tools out there, and you can pretty much choose any one of them, and it'll just do its job. Not necessarily need to be tightly integrated with GitLab. But this is where it gets juicy for us. This is our bread and butter right here. So obviously the version control piece for GitLab is Git. IDEs I know that GitLab works with is Eclipse and JetBrains. There are extensions out there to those tools that you can use, make those tools work with Git. Not necessarily part of GitLab, but they work with Git. Issue tracking, we have our own issue tracker, obviously, and then code review. Our mechanism for code review is merge requests or GitHub calls and pull requests. So code review and merge requests is pretty much a quality gate. They accomplish the same thing. There's different ways to do it, but the whole purpose of code review is about quality. So merge requests, what that does is basically put up your changes for other people to take a look and review them. It's a simple code review mechanism. There's other things that go into that, like approvals. You can nominate how many people have to approve it before it gets merged. You can have mandatory reviewers, like Chad must approve my changes before they go in, regardless of if Phil and Josh give it the thumbs up. Chad's got to give it the thumbs up before it can be merged. So things like that. But merge requests is GitLab's built-in code review mechanism. Testing, this is great for us. I made a typo there. That should be GitLab CI under continuous integration. But GitLab has an integration with Jenkins, which comes in the Enterprise Edition. So we fully support Jenkins there. But more so, we have GitLab CI, fully built in, fully part of the GitLab application is GitLab CI. Testing, they're kind of standalone. They don't necessarily have to be integrated. You just basically call out to these testing tools and away they run. And basically the report that they passed comes back to GitLab as a green light or red light. So they're not necessarily part of the GitLab app, but we certainly work with a bunch of different testing tools. You can use whatever you like. And artifact management, again, you probably wouldn't put artifacts into Git. They tend to be large blobs, binaries. They're a bit too big for Git. They tend to bloat the repository. But there's no reason why you can't use tools like Artifactory and just integrate that with GitLab. And release management and deployment. So again, this is kind of what Sitsi mentioned before. He has got an issue created for GitLab deploy. We're not quite there yet, but really it's just a easier and simpler way to go from GitLab to deployment. It has it would probably look like some sort of hook to another service like Chef or whatever you're using to deploy to your cloud environment. So all I'm really saying is here that we can work with whatever you're using. There's no reason why you can't use any of these tools. They're just not fully integrated somehow into the product yet. But we do have a Docker image for GitLab Enterprise now, which is great. I think we have an Amazon machine image for the community edition, and I've been working with University of California, Berkeley, who is heavy into Amazon Web Services. They are planning to help us put together kind of a best practices document around deploying GitLab on AWS, and hopefully as part of that, we'll get an image, an AWS machine image for the Enterprise Edition. And then the latest news that we got just the other day, of course, is the Cloud Foundry tile. So that's if anyone asks, do you have any kind of ties with any cloud vendors, you could just say, yeah, we have a tie with Cloud Foundry. It's which is kind of nice. Makes it easy to spin up GitLab in Cloud Foundry. Any questions there?
So Hayden, if you go back real quick.
Yep.
So I'm still a little confused on the cloud, because I understand the Cloud Foundry tile now, but explain our relationship or how it's beneficial, or where a customer would want, like if they're looking for a cloud solution, how do we work with AWS or Azure? I know we use Azure internally, but can you just clarify a little bit better on the cloud aspect of it?
Yeah, so there's kind of two aspects to it, but more so one aspect is actually where GitLab runs, where the GitLab application runs. You can run GitLab anywhere. It could be on a piece of bare metal in your closet, or it could run on Amazon. It doesn't really matter where. But in terms of continuous delivery and how our customers are deploying the applications they build using GitLab, they say in the end, let's say it's Salesforce, for example. I think Salesforce has their own cloud, but let's just say the Salesforce cloud, which is the same as AWS cloud or Azure cloud. Doesn't really matter. It's just the Salesforce cloud. Let's say Salesforce was using GitLab to build the Salesforce application, and at the end of their release cycle, they want to push it out to the cloud. They want to deliver the new features to their customers like us. So they would be at the end of the whole process, when they have these packages ready to deliver. They would be, at the moment, there's no direct integration with GitLab. They go to their, whatever tools they're using to deploy to their cloud, and they grab the packages from their artifact manager, and they basically deploy them to the cloud. So this is pretty much talking about how our customers can deliver the applications they build to a cloud environment, not necessarily where the GitLab application runs itself.
Perfect.
Okay, sure. So I broke the strengths into two sections. The strengths over the old kind of tools, the old ALM tools, and the strengths over the kind of the modern tools. So we'll just have a look at the old tools first. So GitLab was kind of fully integrated from the ground up. Previously, what you had, for the most part, apart from a couple of tools, was all these best-of-breed tools. For example, Perforce considered itself a best-of-breed version control system. That's all they did. They just specialized in version control. They didn't do issue tracking. They didn't do continuous integration. That's all they did. So to build an ALM stack, you'd have to buy Perforce, you'd have to buy Jira, you'd have to buy TeamCity, and then hook all these things together to build yourself an ALM suite. Whereas GitLab, it's built from the ground up, fully integrated. So we've got an issue tracker built in. We've got a code review mechanism built in. The SCM piece is Git. It's all built on top of Git. And now we've got GitLab CI, which is a really big piece of the puzzle that's fully integrated. So that is definitely a strength over some of the older tools. Social coding is something that was pretty much brought around by GitHub, and it's kind of fundamental these days. So GitLab enables, or basically facilitates that. We have app mentions, we have the activity feed, we have project dashboards. It's a bit like Facebook for developers. The older tools didn't have this notion. They were really siloed applications. It was really hard to talk to one another. You'd almost have to be sitting in the next cube to collaborate with, your development teammates. Whereas nowadays, people develop from anywhere pretty much, but you've got these tools that allow you to work closely together. And that's definitely a strength over some of the older tools. It's Git, which is great. So legacy tools like ClearCase, for example, which is an IBM proprietary version control system, it was really kind of heavyweight, hard to use. Not a lot, unless you were an IBM shop, you really didn't have much exposure to it. So Git's kind of the new kid on the block in terms of version control, and it's clearly the winner. And it's because it's distributed, for number one. Distributed meaning it's local. You can basically clone the whole project to your local machine and do private branching. You can experiment and make all your changes locally. And then when you're ready to share what you did back to the world, you can push it back to the origin and integrate it back into the mainline code base. And that means it's really fast. So instead of in the old days, you'd be tethered to a server that is in some data center across the other side of the country, you'd be constantly talking to the server, checking in and checking out files and making changes. And it was just slow. It's really a lot of latency built into it. But Git, being a distributed tool, is a lot faster. The internal kind of architecture of Git makes it really easy to branch. I know that from working at Perforce, we were what they call heavyweight branching. If you just wanted to make a simple change to, say, the website, like we do, we want to update the pricing page, for example, we create a branch, make a change, we create a merge request, someone like Sitsi approves it, gets merged in, and then it goes live on the site. Some of these older tools, to branch, they would have to create an integration record in the database for every single file in the project. So let's say our website is made up of, I don't know, I'm just going to pick a number, like 20,000 files, text files. When you create a branch in some of these older tools, it would have to create a record in the database for every single one of those 20,000 files, even though you only touch one of them. Whereas Git uses a different tracking mechanism, and it makes branching really, really easy and fast. And that's a definite strength over some of these older tools. And the last two there, working offline and Sandbox, that kind of goes back to the distributed nature of Git. You don't have to be connected to a server. Once you clone the project, you can unplug from the Ethernet, jump on a train, and work away. And Sandbox is kind of a similar notion. Sandbox meaning that you can make mistakes, you can experiment locally before sharing it. So no one sees all the mistakes you made or the experiments you did. You can clean that mess up before you actually contribute back to the main project. And these are all definitely advantages over older systems. GitLab is lightweight and it's easy to deploy. Other tools, they're really cumbersome to deploy. There's multiple components. You got to stitch them together. Whereas GitLab, it's a single application and it's really simple to deploy, especially with the omnibus packages that we got. And that's an advantage over some of the older tools. And I think another good advantage is it kind of builds in, modern best practices for development. And if you're familiar with GitLab Flow, we kind of enable that workflow out of the gate. It's kind of built on that. Merge requests is another best practice. It's kind of like code review, and it's really simple and really easy. And it's the same with approvals, which is part of that code review. Any questions on those? So these are the strengths that GitLab has over some of these older tools. And then if we look at the modern tools, so I'm talking things like Stash or Bitbucket, Server, and GitHub, they're kind of our main competitors. These are the strengths that I think we have over those. We're open source, number one. Customers can inspect the code, they can see what's in the product, which is, people really like that these days. I think just the peace of mind knowing that they can go in and look through the code is kind of ticks a box for us, whereas other tools are not necessarily like that. Another strength is fully integrated CI. I think that's a really big win for us. GitLab CI is, as I said before, CI is a big, big part of continuous delivery, and we have our own fully integrated CI tool. And I think that's a strength over some of the other tools that they may have their own CI tool, but you have to stitch it together, like say Bamboo from Atlassian. You have to stitch that up with Bitbucket Server. It doesn't come fully baked in. I think our back-end architecture at GitLab is a strength, especially over GitHub. It's basically just a black box that you run as a web application. There's not much, you can't get root access to it. You can't split up the application server, the web server, and the database. Whereas with GitLab, you can. It makes it easy to run in cloud environments and scale it better. I think that's a strength that we have. And again, it supports Git. So, we're still competing with things like Perforce and Plastic and Road Code, Team Foundation Server for Microsoft, and still Subversion. But we talked about the benefits of Git, and that's a strength over some of these other tools in the market that don't support Git. It's faster, it's lightweight, and there's a huge ecosystem built around it. And another strength is the fact that we release on the 22nd of every month. We're constantly pushing new features out the door in pretty rapid succession. You'll often see, I think Perforce used to do like one release every 6 months, and I think they still do that. That's kind of slow. So there's a lot of time between drinks for Perforce customers to get new features. Whereas with GitLab, I haven't seen new many features pushed out more than 2 releases. Usually they're out the door pretty quick, and I think that's a strength. Any questions on those?
The thing is great. I'd also add, I think we're just much more cost effective. I mean, when you start adding on all some of these tools where someone's going for Bitbucket or GitHub, it all adds up when they're buying the tools that come with our platform. So I just would add cost effective.
Yep, absolutely. Yeah, we're definitely the most affordable Git management solution on the market, I think.
Hey, Hayden, would you say, is there one area that we're lacking compared to the competitors? Or like one specific thing that I've been asked about that I know that we'll never do is how GitHub can masquerade as an SVN kind of repository as well. Is that very important, or is that like a pretty one-off request, or is that a major advantage that they can do that? Just anywhere, I guess, that you see that we're a little bit behind.
Yeah, that's one of those kind of edge cases where people have, legacy projects in Subversion that probably will never migrate to Git. Maybe it's too hard for them, or the application's too big, or whatever, and they just want to have some way to link, Git with Subversion. GitHub did something there. There is an open source tool that you can use. I think it's called Git SVN. But it's probably just not as polished as GitHub. I think that's an edge case for people that have, legacy projects in something like Subversion. And often, when we're talking to really large prospects, that'll often be the case. They'll have projects that will never get out of ClearCase. They'll never get out of Subversion. They'll never get out of Perforce. But they might want some sort of bridge between GitLab and those tools. It's not really, I don't think it's our core mission to do those sorts of things. We're kind of building something for the new architectures, the new microservices architectures, and the way people develop these days, rather than adapting it to the older methodologies. I would say if we were to lack anything, it would probably be maybe the issue tracker. We know Jira is like the most popular, and it's really, there's a lot baked into that product. It's almost, some people say it's too big and too cumbersome, and there's too many knobs and bells and whistles. But nonetheless, it's a pretty robust issue tracker. There's a lot of different things you can do with Jira, whereas our issue tracker is pretty lightweight. It does the core bit really well, and it's nicely integrated with the rest of the pieces of GitLab. But it may not be the be-all and end-all for issue trackers. People may want a little bit more out of it than that. That's all I can think of, really.
Great, thanks.
Sure.
Hayden,
Yep.
Yeah, thanks, Hayden. I have a quick question. touching on what you said about microservices as well as Chad's point to cost effective. I've seen a few people on Twitter say that GitHub's pricing isn't aligned with microservices. And I was looking at their pricing, and what do you think they mean by that? Is that because for every service you might need or another repo, and after a while, you're charged by certain repos versus GitLab, where you should just have as many as you want?
Yeah, I heard that too. I saw that, and I think you're right. That's what I assume. So, yeah, when you're building these components in separate repositories, you're going to have to take out a new private repo with GitHub. So you might have 10 modules or 10 components or 10 microservices that, when they're integrated with some sort of API, they make up the product. And the pricing for GitHub is not necessarily for the big application itself. It's all based on single private repos. So rather than
cool. Yeah, that's what I had a hunch about.
I'm pretty sure that's what they were talking about. And if there's anyone, maybe Sitz or anyone else that thinks otherwise, feel free to pipe up. But I think that's what it was. Okay. Oh, go. Oh, hey, Calvin. I didn't realize you were there.
I was here. So I'm saying on that point of the pricing on GitLab, you see on GitLab.com and GitHub.com. On GitHub.com, when you want a private repo, you have to pay for each repo, like you said. But on GitLab.com, you don't have to pay until you want to host only the enterprise on your own. So like you get up to 100,000 free repositories for absolutely free when you're hosted on GitLab.com. You don't pay a cent. On something like Bitbucket, you are charged. If you have a group, you can only have a group of 5 developers. If you exceed that, you are charged. But we don't charge for that when you are on GitLab.com. But when you want to host it by yourself, that's when we now begin charging you. You want the enterprise edition now, that's when we start charging you. Otherwise, we don't charge you at all.
Yeah, that's right, and that's a big plus for us. I think that's why we've seen GitLab.com explode over the last kind of 12 months. Is the words got out that, hey, GitLab's free for private repos. I'm moving off GitHub. I'm not going to pay them. That's
right.
Great. We've seeded our market. We're getting people using GitLab by offering free private and public repos. I think it's great.
Awesome. Thank you.
Sure. Just a few bullets on takeaways here. So you can pretty much, assume that if someone's not practicing continuous delivery, you're going to get left behind. You just can't iterate fast enough to keep up with, changing market conditions or requirements. So it's pretty much assured that everyone is either practicing or trying to move to continuous delivery. And if they're not, then they probably won't be around in another 12 months. There's a ton of vendors in the continuous delivery space, or the application lifecycle management space. There's a lot, but I think the core tools, and the core tools meaning the SCM and issue tracker, code review, and CI, I think that they need to be really tightly integrated, and that's exactly what we have with GitLab. So I think that's a bonus for us. The other tools, the requirements management tools, the deployment tools, the artifact management tools, things like that, they're kind of adjunct to these core development tools. Yes, it would be nice if they were somehow built in or there were simple hooks to them, but it's not a showstopper. And I think that's really key for us, the fact that we've got these core tools tightly integrated as one application. And then as a follow-on from that, we have a great API, and the fact that we're open source means that people can integrate with us really easily. So what we don't have built in the product, we have the means and mechanisms so other people can either build it themselves with our API, or they can build it, or we can use our own API to integrate with something that's really popular, like we did with Jira, for example.
Hayden, or actually, it's probably more for Sid on this last one, the integration. Would working with or partnering with like a segment.com allow us to speed up the the integration availabilities out there.
So what's segment.com?
API, basically a technology that builds integrations for several technologies out there, and then a customer basically integrates segment.com and flips a switch. So instead of a customer putting in 10 different types of integrations, they only integrate segment.com, or it used to be called segment.io, segment.com, and they just flip the switches.
Most of our customers are on premises. I'm just looking at Segment. It seems it's very SaaS oriented. Although Atlassian is on there, I think they're on there with their SaaS product. So,
okay.
And it's very sync your customers oriented for marketing automation, which is not the typical use case for us.
Okay.
I have to drop from the call to another one. Thanks, great presentation, Hayden. Really great. Thanks.
Thanks, Ed. Have a good day. Okay. Questions? Discussion?
First of all, okay, sorry, you just gone.
No, go ahead, Kelvin. You got it.
Okay, so for me, it's not a question. It's I found this very informative. So yeah, the content was a lot, and yeah, it was like wow. It was really good for me.
Great. Thanks, Kelvin. What were we going to say, Josh?
I was getting back a little bit to the discussion about Jira and maybe our issue tracker, because I feel like, all the requests we have coming in, a lot of people are using Jira. So I guess, do you know why that is? Is it just a really good product that they're already just entrenched in and they're probably not going to switch off of that? Or is it just a lack of kind of our offering? I don't know, just kind of any thoughts, I guess, again, on Jira, since it comes up so much in inquiries?
Yeah, it's probably a bit of both. I think that, people have been using it for a long time, and it's become a really centerpiece of their whole process that they really can't get off it. So they want to make sure that whatever changes they make to their environment integrates with Jira. That's definitely part of it. But I also think that if you look at Jira, if you've ever seen it, and I've used it, it is really flexible, and there is a lot of different things you can do with it. As I said, you can use it for requirements management. Force did that. I know that the development teams were, they would build sets of requirements in Jira, but they also used it as an issue tracker as well internally, since Force doesn't have an issue tracker. So it's kind of multi-purpose, and it's really feature rich. So I think that's kind of the main reason why people make it the central part of their workflow and want to keep it.
Great, thanks.
Hey, Hayden, I got a question. We mentioned open source as being an advantage to our clients. What do we do with clients that are making their modifications to our product? Is there a way for them, do we have a process for them to contribute back that code to the product itself? And then secondly, if not, what do we do to basically keep them on the reservation, so as they upgrade the Enterprise Edition, that their changes upgrade automatically?
Gotcha. Yeah, there's a part on the website that talks about contributions. Contributing, it kind of encourages people to contribute, and the guidelines for contributing to the community edition, that is. In terms of making sure that their changes are compatible with new releases of GitLab, I think that's a tricky one, and that's part of the reason why we want people to contribute back so we can build it into the product, is because every time we make a change, especially big changes like in the database, it may not be compatible with their customizations, and then suddenly they can't upgrade and they're stuck on an old version, and maybe there's a bug in it and they're trapped. So that's definitely a tricky one. I'm not sure there is a way. Maybe that's enforced through the API somehow, to make sure that whatever links they make with, or customizations they use the API for, that it's not going to break when they upgrade. But I'm not sure whether that's true or not. I'm just kind of having a stab in the dark there. Overall, I don't think there is a way to ensure that people's customizations will continuously work when they upgrade. That's kind of the trouble with customizations. They get stuck, like Huawei, for example.
Yeah. Okay.
Yeah. So yeah, all we can really do is make it easy for people to contribute and encourage that they do.
Hey, now I had a question for you. And
yeah, Zach?
That was related to, have you had any stories you could share where someone decided to move off of GitHub? And it'd be interesting to kind of hear from your perspective why they decided to make that choice.
Yeah, Disney's a good one. They had thousands of people on GitHub, and their reason for they didn't switch wholesale over to GitLab. Basically, what they're going to do is encourage people to move by making GitLab cheaper. It was twofold for them. Disney Interactive Media was kind of hemorrhaging money a while back, and they were looking for cost savings, and GitLab being a fraction of the cost of GitHub was attractive to them. So cost was definitely number one. But secondly, the back-end architecture, they were getting to some pretty decent size scale, maybe 5,000 users on GitHub, and they couldn't break up the back end, because again it was just a virtual box with no root access that you dropped into a virtual machine and just deployed it. That was a big reason why they wanted to go to GitLab, because it was more conducive to breaking it up and running it in a cluster, for example. But in terms of, so they were the two reasons. The back-end architecture and the price were two big reasons why Disney is going to encourage their teams to move to GitLab. But in terms of features, there's probably certain things that they have that we don't, and things that we have that they don't. It'd be nice to basically compile a list of those, but they're really kind of down in the weeds. Maybe if there's some little toggle that GitHub developers really love and GitLab doesn't have it. But overall, they're two very, very similar products, as you know.
Thanks.
Sure. I can add on that. So another reason is probably due to, most of the time, GitHub is very popular for hosting very many open source projects. That's why it has become really famous. But after a while, we are more famous on people who want to have like a Git solution on their server. So, for example, on their private work server. So when it comes to that, actually, you get it's much easier to maintain a GitLab installation than the offline GitHub Enterprise installation, not the on-premise GitHub Enterprise installation. So that is another reason that mostly large companies would want to use us.
Yeah, that's true. That kind of falls in the bucket of the architecture of GitLab. Yeah, it's easier for administrators to manage GitLab than it is to manage GitHub. For sure. Thanks, Kelvin. Alrighty. Any others?
So Hayden, really appreciate this. Very informative. I think you get that from all the questions here. So what we're going to do here is